everyone, welcome to the session of Class 9 Mathematics, and I am your Anu again for mathschool.com. Today it's lines and angles and the theorems continued. Last class we saw theorem 1 and the converse of theorem 1 2. That is, we saw alternate interior angles are equal when two parallel lines intersected by a transversal. Now today it's theorem 2. So let's see what theorem 2 tells us. Theorem 2, if a transversal intersects two parallel lines. So if the condition is two parallel lines and a transversal intersects it. Okay, then each pair of consecutive interior angles. What do you mean by consecutive? Consecutive means the next. See, if this is one angle, the next angle to it is consecutive. Okay, so these two angles are adjacent angles nearby. Okay, so this is next to it. Angle 2 and angle 1 are consecutive. Likewise, angle 3 and angle 4 are consecutive. Okay, so then each pair of consecutive interior angles. So interior angles, each pair 1, 2 forms one pair of consecutive interior angles, and 3, 4 forms another pair of consecutive interior angles. So then each pair of consecutive interior angles are supplementary. So what do we mean by supplementary? Those two angles add up to 180 degrees. So we have, that is, we need to prove 1 plus 2. So here 1 and 2, I told you these two are consecutive interior angles. So angle 1 plus 2 is equal to 180 degrees. Angle 3 plus 4 is equal to 180 degrees. This is what we need to prove. So that they are supplementary. They add up to 180 degrees. Now how do we do that? See, from the figure we can say angle 2 and angle 5 are linear pair, isn't it? They form a linear pair. So angle 2 plus angle 5 is equal to 180 degree because they form a linear pair, we know, isn't it? So 2, because it stands on it is formed on the line 2 and 5, on the line L. So 2 and 5 form linear pair. So 2 plus 5 is equal to 180 degrees. And we also know that these two lines are parallel lines. It is given, isn't it? If a transversal intersects two parallel lines, it is given, it is those two are parallel lines. So for parallel lines, we know according to corresponding angle axiom, angle 1 and 5 are equal. Only if the corresponding angles are equal, we say that two lines are parallel. Okay, so 1 is equal to 5. Angle 1 is equal to angle 5. You understand? This is by corresponding angle axiom. Because corresponding angles are equal for parallel lines, isn't it? So according to corresponding angles axiom, we have 1 is equal to 5. So instead of this 5 here, I substitute 1, because since 1 is equal to 5, I substitute angle 1 in place of angle 5. So we have angle 2 is equal to angle 1. See, angle 2 is equal to angle 1, isn't it? Sorry, angle 5 is equal to, so we have angle 5 is equal to angle 1 we have, isn't it? Substituting here, what we have is angle 1 plus angle 2 is equal to 180 degrees. So the equation becomes angle 1 plus angle 2. I am substituting angle 5 to be angle 1 here. So it becomes angle 1 plus angle 2 is equal to 180 degrees. See, I have got the consecutive interior angles, that is angle 1 and angle 2 to be 180 degrees. Do you understand? So how did we proceed? We started with 2 and 5 to be linear pair. 2 plus 5 is equal to 180 degrees because it's a linear pair. So 2 plus 5 is equal to 180 degrees. And we also know if two lines are parallel, the corresponding angles are equal. So 1 and 5 are equal. So since 1 and 5 are equal, I substitute angle 5 by angle 1 here, so that I get angle 1 plus angle 2 is equal to 180 degrees. So since angle 1 and angle 2, the sum is 180 degrees, we say angle 1 and 2 are supplementary. That is, the consecutive interior angles, a pair of consecutive interior angles is supplementary. Okay, now we have proved this pair. So what about the next pair? What is the next pair of consecutive interior angles? Angle 3 and 4, isn't it? Angle 3 and 4. So now how do we follow that? So now we have we have 1 and 3. See, 1 angle 1 plus angle 3 is equal to 180 degree. How it is 180 degree? Angle 1 plus angle 3. How it is 1 and it is 180 degree because it's a linear pair, isn't it? Again, it's a linear pair. Likewise, we have 2 and 4 to be linear pair. So I write angle 2 plus angle 4 is equal to 180 degrees. Okay. Now what do I do is, I take this as 1 and this as 2. Now I add equations 1 and 2. Okay, I just add them. So angle 1, see left side, angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360. Right side I add. So 180 plus 180 is 360. Now 1 plus 2, just now we proved 1 plus 2 is equal to 180 degrees. Isn't it? Consecutive interior angles are supplementary. So we know 1 plus 2 is equal to 180 degrees. So what do I do? 180 plus angle 3 plus angle 4 is equal to 360. I bring 180 to that side so that I have angle 3 plus angle 4 is equal to 180 degrees. 360 minus 180 is 180, isn't it? So angle 3 plus angle 4 is equal to 180 degrees. Therefore, angle 3 and angle 4 are consecutive interior angles and they are supplementary. We have proved them. Okay. So do understand, alternate interior angles are equal. That is theorem 1 we have studied. Alternate interior angles 1 and 4 are equal, 2 and 3 are equal. Now it is consecutive alternate angles. Consecutive interior angles. Consecutive interior angles is 1 and 2. So they are supplementary. Don't get confused. They are not equal. They are supplementary. So consecutive interior angles are supplementary. Likewise, consecutive interior angles this side. Each pair of consecutive interior angles are supplementary. Okay. So that is how we prove. Now the converse of this theorem. What is the converse of the theorem 2? Now we have in this we have a condition that two lines are parallel and transversal intersects it. Then pair of consecutive interior angles are supplementary. Now what is the condition here? It's converse, isn't it? So it should be the other way around. That is, if a transversal intersects two lines, we don't say they are parallel. So it is just given just two lines and it is intersected by a transversal. In such a way, how does the transversal intersect the lines? In such a way that pair of consecutive interior angles are supplementary. So this is the condition here. So a pair of consecutive interior angles supplementary. Then we say that the two lines are parallel. Okay. So if the consecutive interior angles are supplementary, pair of consecutive interior angles are supplementary, then we can say that two lines are parallel, which the transversal is intersecting. So how do we prove them? That is, we need to prove AB is parallel to CD. I told you, for any two lines to be parallel, it is just sufficient for us to prove the corresponding angles are equal. Because according to corresponding angle axiom, when two lines are parallel, the corresponding angles should be equal. Okay. So that is what we need to prove. 1 and 3. We need to prove 1 is equal to 3 because 1 and 3 are corresponding angles here. Okay. So for that we take the pair 2 and 3. See, 2 plus 3 is equal to 180. Why? Because it's a linear pair, isn't it? 2 and 3 are angles which form linear pair. So 2 plus 3 is equal to 180 degrees. Now, what about 1 and 2? What about 1 and 2? They have given, see, the condition is in such a way that a pair of consecutive interior angles are supplementary. So it is given that 1 and 2, 1 plus 2 is equal to 180 degrees. We have, this is given. Okay. So this is the given condition and this is according to linear pair. Now we have 180 degree on both the equations. So let us equate both the equations. 2 plus 3 is equal to angle 1 plus 2. So cancel 2 and 2. We have angle 1 is equal to angle 3. See, angle 1 is equal to angle 3. So these two angles are equal. We have proved angle 1 is equal to angle 3. That is, the corresponding angles are equal. So since the corresponding angles are equal, we say the two lines are parallel. So for parallel, do understand, do keep in mind, for parallel lines, it is just sufficient for us to prove that the corresponding angles are equal. What are corresponding angles? See, this angle and this angle. Okay. So the same way transversal makes angle with one line. See, the same way it makes with the other line too. So those are corresponding angles and those are equal. We have proved them. So that is why we say those two lines are parallel lines. Do you understand? So this is the converse of theorem 2. Okay, now that we have finished two theorems, let us move on to the next theorem. It's quite interesting. So all the theorems are based on the two lines, two parallel lines and the transversal here. So that is what we are studying in this chapter, two parallel lines and a transversal. Okay, we are studying their behavior. Okay, the next theorem is the theorem 3. So before writing the theorem 3, let me explain it with a diagram. See, we have two parallel lines. We have two parallel lines as usual. So let us name it as A, B. AB is a line and CD is another line. Okay. So and it is intersected by a transversal at points G and H. Okay, let this line be L. Okay, or I can name this with points too. Let this be E and F. Okay. So we know, according to corresponding angle axiom, I know these two angles are equal because they are corresponding angles, isn't it? Then according to theorems, we have alternate interior angles to be equal. See, these two are equal and these two are equal. Okay, and this is equal to this angle. Okay, corresponding angles are also equal. So we know that. Now what do we do is, see, the alternate interior angles. Let me take 1 and 2 to be alternate interior angles. They are equal, we know. And let me draw an angle bisector. See, this is the angle bisector of this angle. Okay, and this is the angle bisector of this line. So let us name this as M, the ray to be M, and this ray to be HM. This is GM and this is HM. So these two lines, what are these two lines? These two lines are angle bisectors of the alternate interior angles. Sorry. You need to get it straight. Okay. So this is the angle bisector of this interior angle and this is HN is an angle bisector of this angle. Okay. So let me write it. AGH, angle AGH, okay, is equal to angle GHD. So do you understand what is this angle AGH and GHD? So this angle and this angle are alternate interior angles, so they are equal. I have written it through names. Okay, so AGH and GHD are equal. Now I have drawn angle bisectors to the alternate interior angles. Okay, so if I draw bisectors to the alternate interior angles, then the bisectors are also parallel. So now how do we say that the bisectors are also parallel? So what do we need to prove for parallel lines? That you should keep in mind, for parallel lines the corresponding angles are equal. Okay, so that you should keep in mind, and that is what we are going to prove here. So see, this is, if this is AGH, if this total angle is AGH, then what is this angle? See, this angle is half of angle AGH, isn't it? So, and that is, see, if I multiply both sides by half, if I make it half of AGH is equal to half of GHT. See, AGH is equal to GHT, and half of AGH is of course equal to half of GHT, isn't it? So this angle is equal to this angle. So let me differentiate it for you to understand more clearly. So this is half of AGH and this is half of GHT. Okay. So these two are also equal according to this equation. These two are equal. Okay. Now let me try to explain it. See, these two lines and these two lines are intersected by this transversal. See, this ray GM and the ray HN. Do you understand? The ray, see, this is GM and this is HN. Okay, so this is HN and this is intersected by this line. Okay, so now what we have, this angle to be equal to this angle. See, this angle is equal to this angle because it's an angle bisector, so half of the angles are also equal. Okay, so these two angles are equal. Now this just represents two parallel lines and transversal and the alternate interior angles, they are equal here. So when will the alternate and interior angles will be equal? According to the converse of theorem 1, we know when two lines are parallel, isn't it? When alternate interior angles are equal, then the two lines have to be parallel. So it means, see, these two lines, if alternate interior angles are equal, then also we can say those two lines are equal. So those two lines are parallel. So we conclude that GM, see, GM is parallel to HN. Okay, then also we can say that these two rays or these two lines are also parallel to each other. That is, the angle bisectors of the alternate interior angles are also parallel. Do you understand? Okay. Now this is the theorem 3. That is, when two parallel lines, see, when two parallel lines are intersected by a transversal, then the angle bisectors of the alternate interior angles of each pair of alternate interior angles are also parallel. So these two lines are also parallel. So this is what theorem 3 tells us. Now what about theorem 4, the next theorem? Now we have seen the alternate interior angles and the angle bisectors of it, isn't it? So the next one is, there are two parallel lines and we have a transversal here, and we know these two angles are corresponding angles, isn't it? These two angles are corresponding angles. The same way we name them CD, G, H, sorry, E, F, and this is GH. Okay, now we take angle bisectors of the corresponding angles. You understand? So we take angle bisectors of the corresponding angles. See, we have corresponding angles here. So what do we have? EGB angle EGB is equal to angle EGB is equal to angle GHD, isn't it? GHD. Okay, angle EGB is equal to angle GHD. Okay, because they are corresponding angles. We have said those two lines are parallel, so the corresponding angles are equal. So these two angles are equal. Now we have drawn angle bisectors for the corresponding angles. So what happens? Let me take half of EGB will be equal to half of GHD, isn't it? Will be equal to half of GHD. So what is half of EGB? Half of EGB is this, and half of GHD is half of is equal to GHD, isn't it? Half of GHD is this angle. Okay, so this is, let me write it as M and this is N. So this is what we write, MGB is equal to NHD. Okay, so just to identify the angles I have written. So these two angles are also equal. Now, when you take these two lines, see, with respect to these two lines, we have taken GM and GM. Let me take it separately. So this is GM and this is HN. So I take these two lines separately and I draw this GH. So I draw the line here like this. Okay, I've drawn the line here. Okay, now as these two angles are equal, these two angles are also equal, isn't it? Because it's an angle bisector, both the angles should be equal, isn't it? So EGM is equal to what? Is equal to GHN. EGM is equal to GHN, because it's an angle bisector. It divides the angle into two halves, isn't it? Two equal halves. So since this, I mean, these two angles are equal, likewise these two angles are also equal. Okay, so now let us try to understand. See, this is the angle here, angle 1, angle 2, and this is the angle 2 here. Okay, so we have two lines and a transversal, that is GH, and 1 and 2 are equal. What are these two angles? These two angles are corresponding angles of these two lines. See, corresponding angles of these two lines, because this is just like transversal intersecting these two lines, isn't it? So these two angles are equal. So since corresponding angles are equal, we say that GM is parallel to HN. Now do you understand? So that is how we say that when two parallel lines are intersected by a transversal, then the angle bisectors of the corresponding angles are also parallel. Do you understand? So that is what the theorem 4 states. Now the converse of this is when two, the angle bisectors of the corresponding angles are parallel. Okay, now the converse is the angle bisectors of the corresponding angles are parallel. If they are parallel, then what happens? Then the two lines on which the transversal intersects has to be parallel. So that is the converse. Okay, so if these two lines corresponding angles are parallel, so if this is parallel and this is like transversal, what we have, angle EGM is equal to GHN, isn't it? So I double this, EGM is equal to 2 times GHN. So what is 2 times EGM? This EGM is equal to this, isn't it? So 2 times EGM is nothing but EGB. EGB. And what is 2 times GHN? This is nothing but GHD. See, the initial thing we have obtained again, isn't it? GHD. So EGB is equal to GHD. That says the corresponding angles of the two lines, see, these two lines are equal, therefore the lines are parallel. Okay, so the converse is also true now. So this is according to theorem 4, where we have seen the angle bisectors of the corresponding angles are also parallel. Now the last theorem we are going to see is, we have two parallel lines and a perpendicular line. So let this be L, this is line P and this is line Q, this is angle 1 and this is angle 2. Okay, now I have drawn this to be perpendicular, but we need to prove, what we need to prove? To prove angle 2 is also equal to 90 degrees. That is, the line L, what does the theorem says? A line L which intersects two parallel lines perpendicularly. So perpendicularly means it makes an angle 90 degree with the lines, isn't it? With the line. So with the line P, it makes 90 degree. And if P and Q are parallel, see, if P is parallel to Q, the line P is parallel to Q and the line L is perpendicular to P, line L is perpendicular to P, such that angle 1 is equal to 90 degrees, then what we have? Then we have the line L to be perpendicular. We need to prove line L to be perpendicular to the line Q2. That is, the angle 2 should be equal to 90 degrees. We need to prove this. So how do we prove? It is obvious. If these two lines are parallel, if P is parallel to Q, what does it mean? The corresponding angles are equal, isn't it? Angle 1 is equal to angle 2, because those two lines are parallel, the corresponding angles has to be equal. See, these two angles has to be equal. So 1 is equal to 2. Since we have in the theorem angle 1 is equal to 90 degrees, because the line L is perpendicular to one line, that is P. If it is perpendicular to one line P, then the line L is also perpendicular to the line Q also. That is what we need to prove. Since 1 is equal to 2, according to corresponding angle axiom, since 1 is equal to 2 and 1 is equal to 90 degrees, angle 2 is also equal to 90 degrees. Because perpendicular means the angle is 90 degrees. Do you understand? So this is what the last theorem says. So these are the theorems we have studied until now according to the lines and the parallel lines and the transversal which intersects the two parallel lines. Okay, we have seen theorems about alternate interior angles and alternate interior angles to be equal, consecutive interior angles are supplementary. Then we have seen the angle bisectors of alternate interior angles and the bisectors of the corresponding angles, they are parallel, and then the line perpendicular to two parallel lines. So these are some of the theorems we have done with lines and parallel lines and transversal. Okay, so in the consecutive classes we'll see problems based on these theorems. Okay, so lines and angles, and then lines, transversals and the angles associated with them, so that you'll be able to understand it more clearly. Okay, until then it's bye from Anu. Thank you.